Hello students, welcome to the lecture 6 of week 1, and in this video we're going to start discussing coordinate plane. And coordinate plane is easy to understand, so if you take a point, and point is usually called origin, and draw two perpendicular lines through it. So this would be origin, which is usually denoted by letter O from word origin. And this line is usually called y-axis. And this line is usually called x-axis. So if you take any point over here, let's call it point P, you can draw a vertical line towards x-axis, and we can call this distance between origin and this point on the x-axis to be A. And we can do the same, and this is a perpendicular line, so this is 90-degree angle. And we can do a perpendicular line towards the y-axis from P, and this distance we will call B. So then we can denote P by two coordinates, A and B, where A is called x-coordinate, and B is called y-coordinate of the point P. And the AB is called ordered pair. Why ordered? Because first is always the x-coordinate, and y-coordinate is second. Right, so this is the y-coordinate. So that's a relatively simple idea. So let's try to do a few examples. So in this example, the assignment asks us to plot point P with coordinates 2 and 5, point Q with coordinates -4 and 3, R with coordinates -4.5 and, -2, and point S with coordinates 4 and -3. So let's try to do that. So we're going to draw our plane. All right, coordinate plane. And first we're going to plot point P, which has coordinates 2 and 5. So basically we have to count to 2 on the x-axis, and we have to count 5 units up. So 1, 2, up to 5. So in the intersection of this vertical line and this horizontal line will give us a point P with coordinates 2 and 5. The next point we need to plot is point Q, -4, 3. So we have to go -1, -2, -3, -4. And we have to go 3 units up, which is over here. So the intersection of this vertical line and this horizontal line will give us point Q with coordinates -4 and 3. Then R would be at -4.5. So if this is -4 and this is -5, it will be in the middle over here, and it goes -2 units down on the y-axis. Usually we put X and Y to denote the axis. So let's do this out. Vertical, horizontal. This is the point R, denoted by -4.5 and -2. And the last point that we need to do is point S, which goes 4 units to the right and 3 units down. 1, 2, 3. So 3 units down and 4 units to the right. So this is the point S with coordinates 4 and -3. So that's a relatively simple exercise, just to remember the things for the future. And one small idea that is going to be useful for us is to take the XY plane or Cartesian plane and subdivide it into 4 parts. This would be quadrant 1, and both X and Y are positive in this quadrant. This will be quadrant 2, and Y is positive but X is negative, so I have minus and plus. For quadrant 3, we have minus and minus for both X and Y. And for the last quadrant 4, we have plus for the X and minus for the Y. So this is a quick introduction to the Cartesian plane, coordinate plane. And the next small idea that's going to be about distance between points. So if we want to talk about distance between 2 points, and let's denote the points P to be with coordinates x sub 1, y sub 1, and Q would be with coordinates x sub 2, y sub 2. So let's create a new page to move to it. And so graphically we have something like this. Graphically we have y-axis, we have x-axis, we have our first point P with coordinates x sub 1, y sub 1, and we have another point Q with coordinates x sub 2, y sub 2. So what do we want to find? We want to find the distance between these 2 points. So let's suppose the distance is L. All right, so basically what people do, they build up technical issues. So what usually people do, they build up this line and they build up this line over here. Why? Because this would be 90-degree angle. So, and this is a right triangle, therefore. We need to find this vertical distance over here. And let's remember this coordinate over here is y1, and this coordinate over here is y2. So if we take y2 and subtract y1, we're going to get this vertical distance, or distance between these 2 points over here. But since we're not really sure whether y2 is bigger than y1 or y1 is bigger than y2, so theoretically speaking, q could be below p, and then this distance will be negative, but we can't really have a negative distance. So what we can do, we can make it into a positive distance by taking an absolute value. So we figured out the vertical distance, and now we can figure out the horizontal distance. The horizontal distance will be between this point x sub 1 and this point x sub 2. So if we take a difference between x sub 2 and x sub 1 and put an absolute value on it, then this would be the positive distance. Last thing to do is to use Pythagorean theorem that says if you want to find L, you have to, we know that L squared is equal to 1 Lec squared, so x2 minus x1 squared plus the other Lec squared, which is y2 minus y1 quantity squared. But we know that any number squared is positive, so we can remove the absolute value sign from x2 and x1 and y2 and y1. So L squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And the last step would be to take a square root on both sides. So L is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And this would be the distance between 2 points. Just a note for the future, we're going to use this difference between x2 and x1 very often. It's very important quantity for us. So it's usually called delta x, and it's x2 minus x1, or in the other words, this is a change in x. And for the y, we can say delta y equals to y2 minus y1, and that means change in y. So this symbol is a Greek letter delta. Greek letter delta, and this is an uppercase one. Uppercase. Didn't spell it right. Uppercase delta in Greek language. All right, so delta x is just a one variable. It's not delta times x. Delta x is one variable, not delta times x. All right, so we discussed this a little bit. Let's do an example. So in this example, the assignment asks us find the distance between -1 and 2, that's coordinates of 1 point, and 3 and 4, these are the coordinates for the other point. So our rule says if you want to find the distance between 2 points, you have to take x2, subtract x1 and square it, then take y2, subtract y1 and square it, then add those two numbers together, and then take a square root. So let's call this x1, y1, x2, y2, and so we're going to get the square root of 3 minus 1 quantity squared plus 4 minus 2 quantity squared. Now we simplify. So minus and minus 1 gives us plus. So we're going to get 3 plus 1, which is 4 squared, plus 2 squared. 4 minus 2 is squared. 4 minus 2 is 2, and 2 squared we write over here. So final simplification gives us square root of 16 plus 4. And this is the square root of 20. And for a lot of practical purposes, it's good enough for us. If you want to really simplify it, you have to write it as 4 times 5 for the number 20. And why do we write it in this form? Because we can take a square root of 4, which is 2 square root of 5. But again, for all practical purposes, this is a good answer for us. All right. And one last idea for the first week is a midpoint. So midpoint. So it's easy to find the midpoint between two values a and b. So that's going to be just the average of the values, right? The average of two values, so it's a plus b over 2. But the same we can do in 2 dimensions. In 2 dimensions, we just, if we have 2 points, one is denoted by x1, y1, another one is denoted by x2, y2, and we have our x and y axis. So what we're going to do, we're going to say this is x1, this is x2, and the middle of this line segment would be x2 plus x1 divided by 2. So this point will be over here. And the same we can do for the y-axis. This would be y1. This would be y2. And the middle of this line segment would be y2 plus y1 over 2. All right, and this point over here would be exactly the midpoint of the line segment between x1, y1 and x2, y2, denoted by 2 quantities, x2 plus x1 over 2, comma, y2 plus y1 over 2. All right, so we can say that the midpoint of the line segment connecting 2 points P with coordinates x1, y1 and Q with coordinates x2, y2 is the point with coordinates x2 plus x1 over 2, y2 plus y1 over 2. That's the definition of the midpoint, and we figure out how to get it. So one example to finish this week is this example. The assignment asks us to find the midpoint, of the line segment joining 3 and -4 and 7 and 2. All right, so we say that midpoint is equal to, so we take x2, which is 7, we add x1, which is 3, we divide by 2, we put a comma, we take 2, we add -4, we divide by 2. So we have 10 over 2, and we have 2 plus -4, which is -2 over 2. Finally, we have 5 and -1. So let's try to show it on the picture. One point that we have is 3 and -4, so 1, 2, 3. 1, 2, 3, 4. So 3 and -4 will be point over here. And another point we have is 7 and 2. So we have 3, 4, 5, 6, 7. And the positive 2 is over here. So we create a line segment, and our midpoint is at 5, -1. So let's count 1, 2, 3, 4, 5, -1. Let's see if we're gonna get an accurate picture. Just tiny bit off, but again, I'm doing it by hand, so just tiny bit off. This is a midpoint, 5, -1. So this lecture is probably a good point to stop, and that concludes the video lectures for this week. See you in the next week.